Okay, join me on page 558 in the reading textbook and follow along. The genre of our story this week, nonfiction, presents facts about a subject in a direct, accurate, and up-to-date way. Analyze text structure, description. As you read, fill in your description chart, and this chart will be available in your Google Classroom. And read to find out what are some of the qualities of ice that make it so powerful. So what are some of the qualities or characteristics? What about ice makes it so powerful? And 558, follow along.
Icebergs and Glaciers by Seymour Simon.
And he's an award-winning author, or she. Okay, 560, follow along.
For most of us, spring means the return of warm weather. Snows melt and frozen lakes and rivers thaw. The icy scenes of winter begin to disappear. But some places are cold all year round. This photo was taken at midnight during the middle of summer in Antarctica. At that time of year, the sun never sets during the night, but remains low in the sky. Antarctica is always covered by deep layers of ice and snow. So too are parts of Greenland, Canada, Alaska, and Iceland. Even when summer comes, ice and snow cover about 1/10 of Earth's land surface. The upper slopes and peaks of high mountains all over the world are also covered by ice and snow. These places of everlasting snow are said to be above the snow line. Summertime snowfields are found in the Rockies, the Himalayas, the Alps, the Andes, and even at the equator high atop Mount Kilimanjaro. It is in the constantly cold lands and above the snow line that glaciers are born.
Okay, turning the page, 561, follow along.
A single snowflake is a feathery crystal of ice about the size of your fingernail. Every snowflake is six-sided, yet each has a different shape. Once the spinning flakes fall to the ground, they begin to clump together and lose their pointed beauty. Soon the snowflakes become rounded grains of ice with tiny bubbles of air trapped inside. As more snow falls, the weight of the snow and ice squeezes the grains of ice together, forcing out the trapped air. The color of the ice begins to change too. The white of airy snow becomes the steel blue of airless ice. Finally, the blue ice crystals begin to pack together into a solid field of ice. As more snow falls, the ice field becomes thicker and heavier, pressing downward with great force against the ground. As years go by, the ice field grows until it is about 60 feet deep. Then something strange happens.
Okay, turning the page, 562, follow along.
The huge mass of ice begins to move. The ice bends and cracks and begins to slide over the ground, moving downhill. The ice moves slowly, usually less than 2 feet a day, and sometimes only an inch or two. But however slowly, when an ice field begins to move, it has become a glacier. Glaciers are sometimes called rivers of ice, but a glacier moves differently than a river. Water flows freely, but ice is hard and can crack easily. For many years, scientists called glaciologists have studied how glaciers move. Some of their early findings were accidental. In 1827, one Swiss scientist built a hut on an alpine glacier. When he returned 3 years later, he found that the hut had moved more than 100 yards downhill. In recent years, scientists have found that glaciers move in 2 different ways. One way is by sliding across the ground on a very thin film of water from melted ice. This meltwater, sometimes only the thickness of a page in this book, allows the ice to slide more easily. The second way that a glacier moves is called creep. The tremendous weight of the glacier makes the crystals of ice slowly form layers one atop another. Then the layers begin gliding or creeping over one another.
And here, this diagram shows the two ways. 563, follow along.
All glaciers move in both ways, but some glaciers move more by sliding over the ground, while others move more by creeping. The photograph shows the Bird Glacier in Antarctica. Antarctic glaciers move mostly by creeping.
564, follow along.
Different parts of a glacier move at different speeds. Louis Agassiz, a 19th century Swiss naturalist and scientist, once planted rows of stakes in straight lines across a glacier. The following year, Agassiz found that the stakes had all moved down the valley, but the stakes in the middle of the glacier had moved the farthest. That showed that the ice in the middle of the glacier was moving faster than the ice along the sides. In the early part of the 20th century, Swiss and Italian scientists drilled holes straight down the thickness of a glacier. Then they placed iron rods in the holes. Over the years, the scientists found that the rods bent at the top. This showed that the ice at the top of a glacier moves more quickly than the ice at the bottom. Nowadays, glaciologists use photography and other methods to learn about glaciers. The photo shows a scientist using an instrument called a transit to help find out the speed of a glacier. The thicker the glacier, the faster it moves. That's because the greater weight of the glacier causes the crystals of ice to creep more rapidly. Also, a steep glacier will flow much more quickly than one on level land. Temperature is a third factor that affects the speed of a glacier. The warmer the glacier, the faster the ice moves, because there is a greater amount of meltwater beneath the ice. In fact, scientists sometimes group glaciers together depending upon whether they are cold or warm. But even warm glaciers are still freezing.
Okay, 565, follow along.
Some glaciers move so slowly that you might not notice their movement for a long time. The cold Alaskan glaciers in this aerial photo creep downhill at only about 6 inches per year. But there are some steep, warm glaciers that flow more than 100 feet a day. As the glacier moves, the ice on top bends and sometimes cracks. The cracks in the ice are called crevasses. The crevasses can be deep and wide and very dangerous. This group of scientists exploring the Juneau ice field in Canada has to travel carefully.
Okay, turning the page, 566, follow along.
When glaciers move, they grind and crush everything in their path. Small stones and huge rocks are pulled from the ground and carried along. Slowly, but with irresistible force, glaciers cut and carve the land. Trees, forests, hills, and even mountains are ground down over the years. The photo shows how most of the mountain has been carried away by the ice, leaving sharp peaks and ragged ridges. As glaciers move, they often scratch lines into the layers of rock that lie beneath the soil. The scratches are made by smaller rocks carried along by the ice. Sometimes, glaciers wear down the bedrock to smooth, rounded humps. To some people, these rocks have the shape of a flock of grazing sheep, so they are called roches moutonnées, French words that mean sheep rocks.
And you can actually test this on a smaller scale if you get a cube of ice and you kind of just drag it through some dirt and then pick it up. You'll notice that pieces of dirt stick to the bottom of the ice. And then think about this multiplied many times over by a huge glacier, how big stones and rocks those glaciers can pick up as they slide along. All right, continuing on page 567. Follow along.
The rocks carried along by a glacier are broken down and ground into smaller and smaller pieces. The smaller pieces are ground again and again until they are very tiny particles, almost too small for you to see. These particles, called rock flour, are carried away by a glacier's meltwater. The rock flour carried by the meltwater stream from a glacier has turned the seawater a grayish-brown color. Not all of the rocks carried by a glacier are ground into rock flour. Some of the rocks are left behind, along the edges or at the end of a glacier. Sometimes these rocks build up into ridges or piles called moraines. You can see the moraines in this photo of the Worthington Glacier in Alaska. There are many different kinds of glaciers. Mountain glaciers start in snowfields atop mountains. Then they begin to move downward, following valleys until they reach the snowline and melt during the summer. Mountain glaciers are often thousands of feet wide and many miles long. Avalanches of snow roar down their surfaces. Sometimes mountain glaciers do not melt when they reach the bottom of the mountain. Instead, the glaciers flow over the countryside to form ice fields over the level ground.
Okay, continuing, 568. Follow along.
Bigger than most mountain glaciers are ice caps. Mountain glaciers that have become so thick that the mountain is almost buried. This computer-colored photo of Iceland was taken by satellite. The red spots are hot, active volcanoes. The green and the yellow areas are places where the temperatures are medium. The smaller white spots are mountain glaciers. The large white areas are ice caps. Iceland's largest ice cap covers more than 3,000 square miles. There is an active volcano buried beneath the western part of that ice cap. The heat from the volcano is always melting the ice above, forming a huge reservoir of meltwater. Every 5 years or so, the meltwater bursts out from under an edge of the cap. The roaring waters carry large boulders and giant blocks of ice. For miles around, the land is flooded and becomes a vast lake. Ice sheets are the largest kind of glaciers. The Antarctic Ice Sheet is the biggest in the world. It is larger than the United States, Mexico, and Central America combined. In some places, the Antarctic Ice Sheet is more than 15,000 feet thick. That's about the height of 10 Empire State Buildings stacked one atop another. Where an ice sheet meets the sea, it forms an ice shelf over the water. Large masses of ice often break away from glaciers or ice shelves. The glacier is said to be calving, and the floating blocks of ice are called icebergs.
Okay, turning the page, 569. Follow along.
The icebergs in the photo are 80 to 100 feet high and several miles long. Each is a floating island of ice. The largest iceberg ever measured was about 200 miles long and 60 miles wide. That's bigger than the state of Vermont or the country of Belgium. As an iceberg floats, it melts, changes shape, and breaks apart. Until an iceberg melts and disappears completely, most of it is underwater. Only a small part of an iceberg shows above the water. About 7/8 of the berg is hidden beneath the waves because glacial ice is slightly lighter than an equal amount of seawater. The large unseen part of an iceberg adds to the danger of a collision with a nearby ship. On the night of April 14, 1912, the Titanic, the safest ship in the world, according to its builders, was steaming across the North Atlantic. Yet in a few hours, the ship had gone to the bottom of the ocean after striking a large iceberg. More than 1,500 people died in the icy waters that night. The next year, the International Ice Patrol was established, and it is still on the job. The patrol searches for dangerous icebergs and helps ships avoid them.
Okay, 570. Follow along.
In the future, icebergs may prove to be useful as a source of fresh water for dry lands. One plan calls for mile-long Antarctic icebergs to be towed to distant countries by powerful tugboats and helicopters. The icebergs would be wrapped with layers of plastic insulation to protect them from melting on their journey. But there are still many problems with this idea, and it may be many years, if ever, before icebergs are transported in this way. 20,000 years ago, ice sheets covered most of Canada, all of New England, and much of the Midwestern and Northwestern United States. Most of Great Britain and large parts of the former Soviet Union, Germany, and Poland, along with smaller parts of Austria, Italy, and France, were also covered by ice. Then, about 10,000 years ago, the ice began to melt. Today, glaciers are found only in cold polar regions and high mountains. During the past million years, glaciers and ice sheets have advanced and covered large parts of Earth at least 4 times, and perhaps as many as 10 times. Scientists call this time the Pleistocene Ice Ages. Pleistocene comes from Greek words that mean most recent. Today, we can see the ways that the land was changed by the glaciers. The rivers of ice cut valleys through the land and made rolling hills. Rocks and boulders were dragged from one place and dropped in other places far away. Perhaps the place where you live now was once covered by ice. If you look around, you may find clues to past ice ages, scratches on bedrock, a big boulder that stands alone, a round pond left behind as the ice melted. Will the great ice ages ever return? Will ice sheets eventually bury New York, Chicago, London, Montreal, and other cities of the North? Or is our climate getting warmer, melting the huge polar ice fields and raising the level of the oceans? Some scientists say that the last century has been the warmest in the past 4,000 years, and it may become even warmer in the next century. But no one knows for sure. Many mysteries remain. Scientists are studying the ice ages and the glaciers of today, and little by little, the world of ice is yielding its secrets to science.
All right, thanks for following along, and I will see you on the next video. You have comprehension questions and test review questions, depending on the day, in your Google Classroom. Thanks for watching.